Hi and Assalamualaikum to Media Ediba and to my fellow friends. Today, me and my group member will present about this topic, determination of a sulfate in an unknown sulfate salt by using the gravimetric analysis. Let's begin. Hi, my name is Anis Mila. I will introduce about gravimetric analysis. Gravimetric analysis is a method in analytical chemistry for a quantitative determination of an analyte based on the mass of a solid. There are two types of gravimetric analysis. First is precipitation method, second is volatilization method. Precipitation method is an analytic technique that uses a precipitation reaction to separate ion from a solution. And for volatilization method, it involves the separating component of our mixture by the heating or chemically decomposing the sample.
For the part theory of experiment, first we explain about the principle of gravimetric analysis. The principle of gravimetric analysis is based on the estimation of the mass percent of ion in an impure compound of known quantity by determining the mass of the same ion in a pure compound. Next, we have the chemical equation. Sulfate is determined precipitate as barium sulfate in a hydrochloric acid medium by addition of barium chloride. After a period of digestion, the precipitate is filtered, washed with hot water until free of chloride, ignite and weighed as barium sulfate.
In this part, I'm going to explain about the methodology or procedure. First is to weigh a clean, dry 250 ml beaker using analytical balance and record its mass. Next, add 0.30 to 0.35 grams of the unknown sample to the beaker and record the combined mass of the beaker with the sample in the result sheet. The second step is to add 50 ml of distilled water followed by 20 drops of 6 molar HCl to the sample. Stir until the sample has been dissolved. Step number 3. While heating up the solution, measure out 25 ml of 0.1 molar barium chloride using a 100 ml clean graduated cylinder. Next, slowly add small portions of barium chloride to the beaker containing the hot solution and observe the formation of white precipitate of barium sulfate. When finished, allow the precipitate to settle in the beaker for about 20 minutes. Step number 5. After settled, weigh a crucible without its lid and record the mass. Step number 6. Fold a filter paper into quarters to form a cone and place it in a funnel. Seat the funnel in the mouth of 500 ml Erlenmeyer flask, which will be used to collect the filtrate. After that, slowly pour the mixture containing the barium sulfate precipitate down into the funnel. When the transfer is complete, use distilled water to rinse the residual precipitate from the beaker. And after all the liquid has drained from the funnel, by wearing gloves, carefully press the top edges of the filter paper together and gently fold the paper into a compact package that will fit into the crucible. In step number 9, gently heat the crucible without the lid to remove the water. Once the paper appears to be dry, heat the crucible more vigorously so that the filter paper begins to char. If the filter paper bursts into flame, you should cover it with the crucible lid to put out the flame. Continue to heat moderately with the lid off until all of the filter paper has turned black. Once all the filter paper has turned black, it is entirely combusted and converted into CO2 gas, leaving only the white barium sulfate in the crucible. Continue to heat the crucible vigorously until no charred filter paper remains. This should take about 5 to 10 minutes. Then allow the crucible to cool at room temperature. Then weigh the crucible without the lid and its contents on and record the mass. Finally, place the crucible and its contents back in the clay triangle and heat vigorously with the lid off for an additional 5 minutes. Then allow it to cool again. Reweigh the crucible and its contents. Record its mass again.
Next is the example of result and data. The first one is the mass of empty beaker. The second one is the mass of beaker and unknown metal sulfate. Third is the mass of unknown metal sulfate. Fourth is the mass of empty crucible. The fifth one is the mass of crucible and barium sulfate. And the last one is the mass of barium sulfate. As for the calculation, the first one is to find the mass of sulfate in barium sulfate precipitate collected. The first thing we need to do is to times the molecular weight with the mass of barium sulfate and divide it with molecular weight of barium sulfate, which we will get 0.166 gram of sulfate. The second one is to find the mass percent of sulfate in the unknown metal sulfate, which we will need to divide the mass of sulfate with the mass of barium sulfate and times it with 100%, which we will get 41.19%. And the last one is to find the mass percent of metal in the unknown metal sulfate, which we will just need to minus with the 100 with the 41.19%, and we will get 58.81%.
Next part is for discussion. In accordance with the theory that gravimetric determination of sulfate can be carried out by weighing and precipitation, which means in accordance with the general understanding of gravimetry, which is a way to analyze a substance by weighing and precipitation. From the experiments conducted on the gravimetric determination of sulfate, it's hoped that it can produce meaningful results because in this experiment, what is needed is not a qualitative value but a quantitative value, where the quantitative value is the presence or absence of a substance and the resulting weight. Before doing the practicum, we must first make the porcelain crucible constant because if it is not constant, it will result in severe calculation errors so that the levels may not be appropriate. Constant means that the difference between weighing and the next is only slightly with a tolerance of 5%. The sample used in this experiment was sodium sulfate, which was dissolved in hydrochloric acid and added with aqueous. Next, the sample was heated to see if there was a precipitate form was immediately carried out by adding a solution of barium chloride to the hot sample solution. Precipitation is carried out in a hot solution because the solubility increases with increasing temperature. When barium chloride is added, the solution becomes cloudy white because a white precipitate is formed, which is barium sulfate compound. Next, the solution was cooled and allowed to separate the white barium sulfate precipitation under the solution. This cooling process is carried out so that the known as filtering. Filtering is done using filter paper. After filtering, the precipitate was washed with distilled water to remove Ba2 plus ion that attached to the barium sulfate precipitate. To test the presence of Ba2 plus ion attached to the barium sulfate, a test was carried out using chloride chromium solution. If the water resulting from washing the precipitation from a yellow precipitate after dropping chloride chromium solution, if can be ascertained that Ba2 plus ions are still attached to the precipitate, if after the drop of the reagent no more precipitate is formed, then the washing can be stopped. In this experiment, the precipitate was washed twice. Water is used to react with barium sulfate compounds and can dissolve Ba2 plus ions. After that, the filter paper and precipitate were dried and then put into a porcelain crucible and ignited in a furnace at temperature of 90 degrees Celsius, which served to heat until the filter paper and precipitate turn to ash. And finally, it can be determined the value of sediment mass. Due to time constant, the filter paper and the precipitate did not turn into ash in the experiment, so that the results were as they were. There are several error factors in this experiment, including there is a precipitate that escapes from the filter paper so that the sediment obtained is not optimal. Next, there are deposits that fall spill during filtering, and there are still Ba2 plus ions attached to the precipitate so that sulfate obtained is not pure. There is still filter paper that has not been etched so that the sediment mass obtained is not accurate. In conclusion, the gravimetry is the analysis of substance by weighing and precipitation. The principle of gravimetry is to obtain the desired material or substance along with its pure weight. There are two gravimetric methods, namely precipitation and evaporation method. In gravimetry, we must pay attention to accuracy in work because what is needed is a quantitative value of a substance. In this experiment carried out when adding fluoride chromium to a solution that has been separated from the precipitate, it will turn yellow.
That is all from us. Thank you for watching.